today we are going to start with the cauer1 and cauer2 form of cauer1 and cauer2 form of RC network. Now let us write the ZRC is equal to, we have ZRC is equal to K naught by S plus K infinity plus sigma Ki by S plus sigma I. Now here for the cauers1, what we do, we see the pole at infinity or the value at infinity. As this is your ZRC, we don't have pole at infinity, only the value at infinity, that is K infinity. So we will remove this K infinity and that will be your resistance. This is your K infinity. Now the second term that will come, if you see at S infinity, S is equal to infinity, these two term will be 0, means our shunt impedance will be, means our impedance ZRC is equal to 0 at S is equal to infinity. Means when ZRC is equal to 0, means it is 1 by SC, then only it will be 0. If I put S is equal to infinity, then only it will be 0. So the YRC will be SC, means there will be shunt in parallel to this one. Now after that we are again going to inverse the process, inverse that component. So again we are going to get R and C. This will keep on continuing. Here we need to keep in mind the first part, that is resistance. If you put S is equal to infinity over here, because for the cauer1 our main point is focused to at S is equal to infinity, and as is equal to infinity we are left with K infinity only, and K infinity is nothing but resistance. Rest it will be followed by capacitance, because we have seen ZRC is equal to 0, which is nothing but 1 by S. When it will be 0, when it is of term of 1 by SC, and S is infinity, then it is 0. So YRC will be SC, so there will be a capacitance in parallel. So this will continue. This is your cauers1. And for cauers2, what we see the value at S is equal to 0. Now and we don't see the ZRC, we go to YRC. Now if you write the YRC, it is nothing but K naught by K infinity S plus sigma KIS S plus sigma I. Now if you see S is equal to 0, these two vanishes and we are left with K naught, that is your admittance. This is your admittance, and remaining term is 0, means YRC is equal to 0. If I remove this component, then remaining term is 0. When this will be 0, when you have admittance SC form, or ZRC will be 1 by SC, or we have one capacitance in front of this one. So and rest it will keep on continuing, this R and C. So this is called cauers2 form. So here what we are eliminating, the DC portion we are eliminating. Here we are eliminating the infinite, means the highest term. So to get the rest of the value, what we do, suppose the function is ns by ts, then what we do, we divide with ns and we keep on continuing fraction. Continued fraction is followed with the highest power. It is followed with the highest power because we are looking at removing infinite term, that is why we start with the highest power, means whichever the highest power of S. And here we remove the DC component. Suppose the function is s square 9 s plus 1 2 plus s square 8s plus 2. Suppose this is the function, then we try to remove the DC component. So we do in this manner, 2 plus 8 s plus s square, means we keep on dividing with this term. We will dividing in this manner, 2 plus 8s plus s square divided by 1 plus 9s plus 9s square, because we want to remove the DC component. So this is the difference between the cauers1 and cauers2. Now let me take the one example so that we will study the cauers1 and cauers2 in fully manner. Now taking one example. Now suppose zs is s square plus 8s plus 12 by s square 4s plus 3. Now this is your zs that we have taken. Now we will be dividing this with the numerator for the cauers 1. 8s plus 12, the highest power is going to be divided. Now we are keeping 1, this will be your z, and writing the 4s remaining portion. Now we are left with 4 plus 9, again making this value here. Now what will be s square plus 4s plus 3. Now what it is going to come, this is going to come 3y sy 4, and it is nothing but y, because first term was impedance, the second term was admittance. Now if you divide this one, now you are left with s square 9 by 4s. If I subtract, then we are left with 7 4 by 4s plus 3. Now this term again appears here, 4s plus 9. Now if I divide by 16 by 7, then this is your z term. Now let me divide, this will be 4s by 48 by 7. Now if I subtract, this will get cancelled out, and we are left with the 15 by 7, and this term will appear here. This is nothing but 7 by 4s plus 3. Now if I divide, we are going to get 49 by s. Now this is going to be, this was your z, then again this is going to be y. Now we are left with 7 by 4s. Now we are left with 3, 15 by 7. Now if you divide by 1 by 7, this will be your 5 by 7, then this is going to give you the real value. Now you divide by 5 by 7, then it is going to 50 by 7, and this is going to be 0. Now if you take first term was z, now let me write this one, z as 1 plus. Now if you take 1 plus, now taking 1 by, this is the term that we have infinity at k infinity that we are taking. Now this is 1 by 1 plus, now it is s by 4, and then again we are reviewing again second term. This will be 1 by 16 by 7, this term we have taken 16 by 7, and then again putting 1 by 49 by s, 49 by 60 s, this is your 49 by 60 s, so writing 49 by 16 s. Now again 1 by 5 by 7, so this will be your cauers 1 form. Now let me draw the cauers 1 form. The first term will be k infinity 1, the second term will be followed by 1 by 4, and the third term again resistance, it is 16 by 7, this is your 16 by 7, and again it will be your capacitance 49 by 60. Now this will be your resistance with 5 by 7, so this is your cauers 1 form. Here what we need to do, here we need to remember that we try to eliminate the infinite term. In order to eliminate the infinite term, we start with the highest power and continued fraction we can go on. Now let me take to cauers 2 form. Now if I take cauers 2 form, then I have to write the y of s. If I write y of s, it will be 3 plus 4s plus 4s square plus 12 by plus 8s plus s square. Here I have taken in the lowest power form because we need to remove at we have taken y s, and we need to remove at the value the DC component, so we have taken the in a lowest minor. This is the logic, we are taking the lowest power. Now let me divide 3 plus 4s. Now 3 plus 4s plus s square. Now if I divide with 1 by 4, this will first term will be y, and 3 by 2s plus s square by 4. Now it will be subtracted. Now we are left with 2s by 3 by 4s square, and this term is going to appear here, 12 plus 8s plus s square, and if I divide with 6 by s, this term will be z. Now we are left with 12, 9 by 2s. Now what we are going to get, 7 by 2s plus s square, and this is going to reappear here. Now if this cell appear 2s plus 3 by 4 s square, and it is going to be 4 by 7, and 2s plus 4 by 7 s square, it is going to be 5 by 28 s square, and it is going to 7 by 2s s square. Now if I divide with 98, now if I divide 98 by 5s, then what we are going to get 7 by 2s, and here s square, and this is going to come here, it will be 5 by 28 square, and here we are going to get 5 by 28, and here 5 by 28 s square, and we are going to get 0. Now we got the term, the first term y, then z, then again this will be y, then z, and then y. These are the terms that we got it. Now let me write the cauer's to form YRC is equal to, first term 1 was YR 1 by 4 plus 1 by 6 by 5 plus 1 by the second last 4 by 7, then the next term 1 by 98 by 5s plus 1 by 5 by 28. So these are the value that we got it. Now let me draw the cauer's to form. The first term will be your 1 by 4 and resistance, sorry, it will be your resistance, and that will be 4 because admittance is 1 by 4, and the second term will be 1 by 6, this is capacitance, this is in admittance form, so 1 by 6, and then it will be followed by resistance, that will be 7 by 4, here it is 4 by, this is resistance, so it will be 7 by 4, again taking capacitance will be 5 by 98, now taking resistance it is going to be 28 by 5. So this is your cauer's to form. Here what we have done, we have just removed the value at the DC value, that is why we have taken from the lower order value. So this is all about the cauer's 1 and cauer's 2 for the RC network.